morning, everyone. It's nice to see all of you on this virtual forum, and I do hope all of you are doing very well. It's quite daunting and intimidating to be facing an audience full of developers, PowerShell users, because you are all neck deep in technology, and I'm at best a technology enthusiast. So I just hope that what I have put forward in the next few minutes for all of you to peruse through and understand, you find it hope insightful and interesting. My name is Vikas Bhonsle. I am the CEO of Crayon Software, and we work in the space of cloud and software. So while I want to really talk about the future of multi-cloud, I think it's important we start with the foundation of cloud. Now, cloud is a panacea for various things, right? We've used it to talk about it being flexible, it minimizing capital expenditure, it having offering better security, competitive edge, and so on and so forth. But for all of us, it is important for us to know that cloud really is not a label. It's not something that you just speak about and forget it. It's about cloud solutions can solve real life problems. And I think we need to start looking at the cloud to that prism, that this is something that can help us solve problems for enterprise customers, for mid-market customers, for small and medium businesses, for startups, because the cloud in itself has huge potential, right? When I look at cloud from essentially a developer community, I think it is important that I bring out what are the inherent advantages of using the cloud for developers. First of all, it's all about scalability, right? In the old traditional ways of developing your software and systems, you needed to configure the database, the storage, the clustering nodes. It required extensive amount of planning. And of course, it also cost you. Today, scalability is instant because you can instantly bring up servers. Auto scaling features with most cloud providers can spin up VMs very, very instantly. So it's very easy for you to scale up apps in a cloud world. Then, of course, is the whole paradigm of cost. And cost is because there is no upfront investment. You are paying as you go. And in many instances, you do not even need to go and invest in a separate data center to have redundancy, to have disaster recovery, because everything is there for you on the cloud. As a developer, it is important that you are able to quickly provision your resources to get your UAT environments up, to get your test and dev environments up. It is important that there is tremendous amount of agility in the provisioning of the resources, and that's exactly what the cloud provides you. It provides you different models. You can create solutions on a PaaS platform, on an IaaS platform, on a SaaS platform, and the options are innumerable. Then again, if you look at the whole thing about geographic reach, today, most of the cloud providers have data centers not only in one location, but in multi-location. So you can essentially host application in geographies which are more closer to the users. And then you can have solutions like CDN, which can serve images and files and what have you to the users in doubly quick time. And not to talk about all the advanced cloud services that are there across most of the hyperscaler services that you get today, right? Whether it is on AI, whether it is on storage, whether it is on database, whether it is on compute, whether it is on CDN, there are a host of services available. These essentially are advantages that the developer community gets from the cloud. So hence then, what is multi-cloud, right? What is this whole paradigm of multi-cloud all about? Now, different people define this differently, right? Some say it's combination of different clouds. Some say it is on-prem, on the cloud. Some say it is public. Some say it is a mix of different kind of hyperscaler clouds. And there are different ranging definitions of multi-cloud. But if you really look at what's happening in the enterprise world, the enterprises are getting appified, so to say. Your applications are residing in the cloud. When they reside and they breathe and they live in different clouds, you call that multi-cloud, right? The popular wisdom always was that why go to multiple providers? Why don't you just go to one provider? But given the scale of services, given the kind of mapping of usage to the kind of services that are available, and given the fact that today you don't want to have a vendor lock-in, or you do not believe that a single cloud model uh, could serve all your purposes and that there can be no compromises, it's important that you start looking at multi-cloud. For the sake of our discussion today, multi-cloud means a combination of hyperscaler clouds. It could be AWS and Azure, Azure and GCP, GCP and Alibaba or whatever else, right? You know, it's very different from hybrid because hybrid is essentially a combination of on-prem and public cloud services, and there is a fair amount of coordination and orchestration between the two. But when you really talk multi-cloud, at least presently today, there is very little orchestration between the various public cloud providers. So in a way, you can look at multi-cloud as a hybrid cloud, which is running in different public cloud providers. Essentially, if you were to go to really layman definition, that means when you do not want to put all your eggs in one basket, that's when you start looking at multi-cloud. So what's this journey about multi-cloud, right? And I've been in this industry for more than 25 years now. So I thought I will, go back, jog my memory over the past few years and really start talking about how has this journey really evolved. So in my days when I was actually on the field, in the field as a customer-facing resource, trying to sell technology to our customers, cloud has been there ever since 2000. Mid 2000, late 2000s. The past decade, I've been hearing about cloud ever since I've been selling. But the offtake of cloud has never happened in the past for various reasons. One of the reasons, of course, was people did not want to cede control. They wanted everything within their premise. They did not believe everything that leaves the premise is secure. They did not have the skill set to really manage something which is going out on the cloud. And what are the policies that you will have to make sure that everything on the cloud resides on the cloud? What about cloud retribution? All of those things. There were so many issues there. Talent was absolutely scarce. Vulnerability were more. In fact, in the good old days, what used to happen was if you had a problem, you threw people at problems. Right? You have to manage something, put in a lot of people. And that's how the world was. Cut forward to today, and we've all spoken about how the pandemic has accelerated digital transformation, how cloud is the foundation of any path-breaking solution that you speak in the marketplace today. And that's what has happened today. Cloud has become fundamental to everyone's strategy. It's no longer an IT strategy, it's become a business strategy. There is no longer the worry about security. So what were blockers earlier in the past have become enablers today. Because we all are saying, the larger cloud service providers, of course, are going to have better security frameworks than an individual enterprise customer. Greater performance. Cost is a double-edged sword, and we'll talk about it as we go along this presentation. But performance, scalability, uptime, the various solutions that are available in the cloud today are humongous. And that's what we are looking at, speed and automation, right? But when you really start looking at the future, okay, the future is slowly moving towards more deeper technology. It is in today, especially from an Indian context, right? We're still not as mature as some of the developed markets. We are still far away from real use cases of AI and blockchain and IoT and all of those things that we keep hearing day in and day out. But in the next 1 or 2 years, this is going to be real. What it will mean that you'll have to use the best of breed services across different cloud service providers to be able to bring a solution to life. And that could be across containers and serverless and IoT and AI and what have you. And when you really look at those kind of possibilities and the benefits it has with respect to compliance, with respect to innovation, with respect to business efficiency, the future is multi-cloud and the future is here to stay. Of course, there are issues about portability, there are issues about orchestration, and today most of the cloud service providers are trying their best to see how seamlessly workloads can start moving across different clouds. The hybrid multi-cloud is the most talked about thing today in the marketplace. And for everybody here, it's, I added one statistics, which I found very difficult to believe that even today, is just 1 out of 5 enterprise applications which are running on the cloud. So the opportunity here is just simply humongous, simply humongous. These are proof points that I wanted to talk to you about. This is what people are talking about. IDC says by 2020, more than 90% of enterprises will really rely on multi-cloud to meet their needs. But look at some of the other comments that people are talking about. We are talking about edge computing here. We are talking about how organizations are fearful of being locked in a single global service provider. We are talking about why it is impossible to stick to one platform and one provider, because the plethora of services that are available across different platforms, make it so much more sensible, to make use of this best of breed solutions across different service providers. And given the pace of innovation and given where the future needs to go and given what we want to do in a digital transforming world, it's an absolute no-brainer that multi-cloud is here to stay. Just as I move forward, so that you know that what are we going to really talk about, this is the Gartner's Magic Quadrant for cloud infrastructure and platform services. Who are the leaders in this quadrant? It is the names that you constantly hear about: AWS, Amazon, Microsoft, and GCP Google. On the visionaries, you have Alibaba Cloud. And on the niche players, you've got Oracle, Tencent, and IBM. When you really look at, and I'll talk very briefly about each one of them. Alibaba, not too much of a footprint in India. They did try on at least a couple of occasions, but I do not believe they have a very significant footprint in India. Very, very strong in China and Southeast Asia. Very good solutions for digital businesses. Amazon is the market leader in India as far as cloud services is concerned. Very, very efficient engineering supply chain. Large businesses are banking on them, especially if you really look at the startup community. The people who we today talk about unicorns, a lot of them traditionally banked on AWS and absolutely an innovation leader. The guy who is making tremendous stride in the marketplace, is Google. The revenue is growing. They are getting a growing enterprise mindshare, and their Kubernetes service is one of the best in class. IBM, Oracle, pretty confined spaces. Oracle confined to lift and shift of their own Oracle specific workloads. Yes, they are making also big moves in this space, and you will very soon start to hear about Oracle Cloud a lot more. IBM has a little bit of a problem with legacy perception, and they are largely telco and financial services market focused. Microsoft, of course, has the broadest capability set, has the longest relationship with enterprise customers. Very complex in licensing policies, that's what the market says. But they are kind of constantly innovating, and today I think they have a very, very broad set of offering across all platforms and all kinds of different services. This is the kind of landscape that we talk about when we talk of a multi-cloud world, and as developers and application providers, this is the world that you will start building your applications in. Why is the future multi-cloud? Right? I just wanted to spend some time talking about the benefits, challenges, and best practices. And I'll kind of quickly run through this because it's pretty straightforward. The benefits of multi-cloud: optimized ROI, because you can use the best of breed services from different kinds of cloud service providers. Low latency, you can go and place your solutions in the data center closest to the user so that you are avoiding multiple hops. Low downtime, if your service is across one CSP phase, you can immediately switch over. That's the same reason why you will have minimized risk of distributed DOS attacks. We can immediately switch on to somebody else. No vendor lock-in. You don't have to live and die with one person. You can, of course, seamlessly start moving your solutions across different cloud service providers. That poses a different challenge. Yes, but you are not locked into somebody for life. And unlimited scalability and flexibility. You can use data from one cloud service provider, querying engine from some other service provider, and get the best of class results. Challenges. This is something I hear every day. We do this extensively. Migrating workloads from one cloud service provider to the other, from on-prem to a cloud service provider, is one of the most complex issues today. organizations are grappling with it, right? They don't have the people. They don't understand the services that are available. They don't simply have the time to invest in this. Everything needs to be done because, businesses are very hungry. Businesses don't have the patience. So migration is becoming a big challenge across organizations of all sizes and needs. Cost due to poor management, right? As you start looking at solutions that are moving across different cloud service providers, if you are not decommissioning the computing resources that you're using, you will have cloud sprawl, you will have application sprawl, costs will go up, there will be wastage, and you need a proper tool to be able to manage this. It's one of the biggest challenges uh, in multi-cloud computing. The creation of shadow ITs everywhere because people are using certain services of cloud. They are spinning up something from a particular cloud provider, and there is no way to go and manage and make sure that something that has been spun up is kind of destroyed. Data security, very, very big problem. You need to have a absolutely watertight security framework. You need to understand that in the cloud, it's always a shared services model and a responsibility that we're looking at. Talent management, very difficult to get people, even to understand one type of cloud. There are like hundreds and thousands of services on a particular cloud. To be able to do that in a multi-cloud world, very, very difficult. And then, of course, integration, because what you will end up doing is you will end up putting all your key mission critical apps on-prem, low priority app on the cloud. You will do that in a multi-cloud world. And as a result, you'll have a dual architecture running in parallel, which will give rise to a humongous amount of complexity. Hence, it is important to get best practices. Don't do multi-cloud just because everybody is saying multi-cloud. You need to have a proper systems management strategy. You need to understand what kind of a service is ideal for what kind of a CSP. You need to standardize your consumptions. You can say, okay, I'm going to now buy AI services from Azure. I'm going to take the data service from GCP. Let's say the storage solution from AWS. Things need to get standardized so that you are aware of what's happening. There is a certain level of predictability in the system. It's also important that as you start to monitor this multi-cloud system, include your traditional system as part of the overall architecture, because that will give you a lot of efficiency. Okay, increase the use of DevOps tools. It's important that as you start managing this multi-cloud environment, your DevOps tools are extremely sophisticated. You need to have full stack visibility from the user to the cloud. You need to have visibility across the value chain, because that's how you will be able to preemptively understand what are the problems and start updating things. And then, of course, we're going to talk a lot about containers and serverless and some of the best practices which are important in the world going forward. Well, this is not really my area of expertise, but I thought it is important I speak a little bit about architectures, because if you are really have to build very highly scalable and reliable applications, you need to have different kind of applications. So I'm going to take a shot at this. It's an amalgamation of a little bit of experience and a lot of reading. In fact, this whole presentation is about that, and I hope you find it useful. At the basic architecture level is cloudification, which is what we normally do, right? The application is hosted on-premise, and then you are using certain few services of the cloud service providers. You are not using the whole range, but certain few services of the cloud service of the CSPs are used after the migration. That's the cloudification architecture. In the multi-cloud relocation, an application which is on-prem is now rehosted in a cloud environment, and they are now using different kind of a service. In cloudification, it is all about performance. In the multi-cloud relocation, it is all about availability. When you really look at refactoring, it's all about how do you provide a better quality of service. So if you really look an on-prem platform, it is re-architected to work in a cloud world. But one of the application in this example, AC1, is further re-architected into fine-grained services. We can even call it microservices, because by doing so, the deployment of the high usage components is optimized. So they run independently of the low usage ones, which gives you tremendous amount of throughput. And that's what happens in the cloud refactoring architecture. Look at cloud rewinding. And this essentially is saying that as you move re-architect your applications to move on multiple clouds, you're essentially you are bringing in a load balancer. You are bringing in a load balancer between the applications so that if the primary application fails or the platform fails, the secondary deployment is there to take over. So it gives you a high amount of availability. The same can also be done by using cloud brokerage services or by using a cloud broker in between, which effectively reduces the performance a little bit, but you can use that using a cloud broker service as well. And then of course you have a multi-application modernization where all the applications which are on-prem and then which have re-architected and migrated on the cloud are all connected together sort of to create a portfolio of application. And this helps in better management, lower operational cost, and so on and so forth. So depending on what your use is, whether you need high performance, throughput, availability, lower operational cost, there are different architectures available for you. Now, I'm stuck. I'm going to talk a little bit about some of the technologies that you really need to focus on as you look into the future. And I think one of the most important one is containers. And when we talk about containers, of course, we also talk about Kubernetes because it is the market leader in container orchestration. Every single large cloud service provider has got a Kubernetes managed service. But what is containers? One of the biggest problems when you have multiple clouds is how do you make sure this application and the workload start to move across different clouds? How do you make sure that there is portability, seamless portability? Containers to a large extent solve the problem because the container in itself contains an entire runtime environment. It has application, it has dependencies, libraries, binaries, so on and so forth, all put together as one package. Thus, any difference in infra when you move from cloud to cloud or OS are completely abstracted away, which means in a way it becomes very seamless to move from one cloud to the other. It's one of the key services in multi-cloud adoption. And as you start to build your application, this is something that you really need to start thinking about. Containers. It also helps you to standardize and automate your continuous improvement and continuous deployment processes. It has chain tools which helps you do that. And I think that's extremely critical from a developer standpoint. It allows software, like I said, to move from one computing environment to another. And I think as far as containers is concerned, I think one of the biggest questions in the world, in the cloud world is, why do you need containers when you already have virtual machines? And I think let me spend a little bit of time around this, right? So VMs are very secure. By nature, they're very secure. In containers, because the OS, one OS is shared across multiple containers, there is a high level of vulnerability as far as containers is concerned. But containers, because of that, are lighter, are much easier to boot up and start running because the microservices within those containers can really get started very quickly, whereas VMs take a slightly longer time to reboot. A server can have n number or much more number of containers because it is very light in resourcing as compared to your virtual machines. However, from a management standpoint, there are tools to manage multiple VMs like the one you have from VMware. But there aren't very suitably good tools that manage containers in the marketplace. However, like we always do, we can always combine the best of all worlds. You can host containers in very light virtual machines that can provide you high levels of isolation and security. So that's something that can happen. So containers are extremely important when you start looking at development in a multi-cloud world. Let's talk about serverless. But serverless, you don't have to worry about anything. As developers, the entire code is run by the service provider. Managing, provisioning, maintaining servers, everything is done by the service provider. You need to just worry about writing the logic and creating the code. That has immense value. If you really want to look at flexibility and security, flexibility and portability, then you have containers. When you need to look at agility, speed, then you need to look at serverless. That's the way it works. However, how much ever has been the hype around serverless, it hasn't kind of unfortunately grown to the kind of hype that it has had. The adoption is still fairly muted. Even as far as the developer community is concerned, I don't think everybody has gone and deep dived into the serverless technology. People are just happy to keep the lights on as far as serverless is concerned. Serverless is also called event as a service, a function as a service, because all that you're running is a function on a particular service, only paying for as long as you're using the function or as long as the event is there. And a great example is, triggering the buying process when you buy the buy button on any e-commerce site. One of the greatest uses of benefits of serverless is it has benefits both ways. At low levels of usage, it's extremely cost effective. At very high levels of usage, it is extremely scalable. So cuts both ways. It enables ease and velocity, as I already said. Portability is all about containers. And the best thing is you can actually compose the best of breed cloud services across different cloud providers to bring in a very, very unique, powerful serverless solution. So this is something that you need to really look at. There isn't much of skill set available in the marketplace today. So this, according to me, is one of the best time for developers, right? You've always been told that, you need to go to market faster, you need to eliminate bugs, you need to have updates, all of that. And some of these technologies, containers, serverless, are absolutely adapted doing it. I need to talk about edge computing. This is where the world will eventually go to, right? What's edge computing? Edge computing is basically you are processing the data at the point of origin. Wherever data is created, you're trying to process it. Why is it happening that way? Very simply because the cloud architecture is a very centralized architecture. And today, with IoT and the millions of devices which are available, it is just not able to cater to the demands of so many endpoint devices in the marketplace today. Okay. Advantages of using edge computing: low bandwidth, because everything is getting processed, so you don't have to worry about processing something and sending it back to centralized server. Imagine a smart car or a driverless car has to kind of pull in the data in the car and then send it to the data center and wait for it to come from the data center. That can be disastrous, right? So they're really computing at the edge is becoming extremely critical. IoT, smart manufacturing, CDNs are great examples of edge computing. However, like with everything else, managing multiple apps spread across various edge locations is a huge headache. It's a massive headache. And I think one of the things you will hear about as you start embarking into your development journey is a term called distributed cloud. And distributed cloud is all about putting together different multiple clouds, different edge locations, even your traditional data centers as one simple cloud. When you do that as one, then all the other issues that are associated in management and the hassles around that just goes away. Data analytics, I don't think I need to speak about it a lot. This tremendous proliferation of data that is happening has given rise to multiple headaches. Data privacy, security, all of these things. Across most cloud service providers, you have services that has completely democratized data sciences. Completely. However, and unfortunately, the visualization tools are great, but the data gathering tools aren't very great. As a result of which, most data scientists end up spending 80% of the time cleaning and preparing data and only 20% of time really working on insights on the data. And that's where this is all moving to. The data world is all moving to privacy and security. And again, I just happened to read something in the Economics Times today that India has got the least amount of data analytics experts in the Asian region. So it's again absolutely low on skill set kind of a thing. Automation and security, containers, excellent example of automation and security, right? Not, of course, as secure as IBM's, as I said, but very secure. They go hand in hand, fundamentally work together. In fact, when we talk about digital transformation, we talk about cloud and automation together. It is built into any foundational cloud solution automation. And when you really look at security, and this, of course, is not a sermon on security because security is such a big, vast subject, is just to say that as you are looking at building an application, you need to have a high level of security and automation built in. They need to be self-sensing, self-managing in many, many ways when they need to start working in a multi-cloud environment. And when you really look at some of the cloud providers worldwide, they have a very high level of security protecting the system, which no typical enterprise customer will have. So just coming towards and trying to wrap up this whole discussion, as you start building on applications with multi-cloud in mind, what are the things that are important? First and the most important, you have to build apps that work in a multi-cloud environment. Because if the apps otherwise starts to just kind of randomly start moving without any kind of orchestration, there is going to be a lot of usage or of resources which are not decommissioned in time, leading to cost, leading to crowd sprawl, leading to application sprawl. So the applications have to be built to work in a multi-cloud environment. The same goes with manual processes. They need to work in an environment which is multi-cloud. It needs to have orchestration. It needs to have a certain level of sophistication when you want to put it into production. Otherwise, you will be having to sit and do all of these things manually, actually delaying the entire process. And then you need to be able to smartly pick and choose. So what do I mean by that? In real terms and in real world terms, it's really, of course, very difficult to build applications that work in multiple clouds. But as you start building your applications, you need to start thinking about a few things. Let me give you some examples. You need to start about what kind of unique capabilities does this app require? Does it require unique AI capabilities, IoT, or some really vertical specific APIs? Then you need to start and go and start choosing that particular CSP, which is good in that particular service. And you need to be very clear that there is a strategy around what capabilities I will build into my application, and hence what kind of a cloud service provider service will I use. You could have a need of geographic presence. You may need to have that app in a particular country or a location because of a number of various residency laws or whatever else. You could also need to have the app very close to the source. You can think of SaaS applications, data centers, and so on and so forth. So I think handling the sprawls, managing the manual process or avoiding the delays, and picking and choosing the right thing is extremely important when you look at the multi-cloud world. I'm going to summarize. What are the key takeaways? What is the world moving to? Why is it very important to you? And this is just a summary of all that I spoke in the last few minutes. So first is, when you look at a multi-cloud world evolving in the next few months and years, we are looking at an era of innovation. Look at containers, you look at serverless, you look at dashboards. We spoke about a lot of orchestration, right? AI-powered orchestration. And let me stop here for a minute. I haven't spoken about AI at all. Because for me, AI is all pervasive. It's almost like multi-cloud. It was pervasive, now it is becoming an industry standard, so to say, almost, right? Best practice, an industry practice, right? Similarly, AI is going to be all pervasive, whether it is the orchestration tools, whether it is about some kind of a billing engine, whether it is about doing some kind of a data crunching, anything and everything will have an AI-powered engine running around. So that's all pervasive. When you look at the world with so many different technologies, it's all about data-driven decision making, which are using tools. You are looking at a tremendous level of innovation that's going to happen in the world, in the globe, across the globe, using the technologies that are available in the marketplace today. It will bring in efficiency, because I believe that digitalization is just not possible unless you allow seamless movement of workloads over different kinds of clouds and allow them to use services across different kinds of clouds. Otherwise, this kind of digitalization is just not possible. Hence, again, it is important that we have the right tools to manage spend, to reduce wastage, All of these things are extremely important. Using the right services across the different service providers. How do we do it? There is a big question of skills. Different cloud providers, different containers, different APIs, security vulnerabilities, shadow IT. Even if you were to look at tools of orchestration, tools for managing, tools for deployment, tools for billing, they're not going to be necessarily one tool. We need to have and build the skill. This is going to be a process of learning. This is about what is the attitude. I need to focus on an attitude to learn. This is all about imbibing a culture in different organizations and within yourself as individuals about learning, because the opportunity is tremendous. The world that's going to be in front of us is all about learning, relearning, and new learning. And that's very important. Security, proliferation, explosive proliferation of apps in the marketplace today. Explosive. Apps are getting launched from private data centers, public clouds, containers, you have it. And if they're not managed properly, the surface area for threats is going to be humongous. There are going to be third-party solutions that you will require to work along with your cloud providers that will give you protection against some of this. Your DevOps teams, all you DevOps developers out there will have to work with security ops, network apps to thwart such security challenges. It's going to be one of the most important paradigms in the future. And it will require very intelligent, automated advances in AI and machine learning, right? So I spoke about AI as an all-pervasive trend. There is going to be no security system available in the future will not have an AI engine running on it, right? And finally, compliance. Unfortunately, we do not have a global standard for data compliance. Data sovereignty laws differ from region to region. Hence, it is important that we have the right regulations, we know about it, we adhere to standards like GDPR, ISO, and so on and so forth. And we have a very, very secure, responsible data management system in place. So that's kind of the key takeaway. So let me conclude. Multi-cloud, without doubt, is here to stay. We need to start, to my mind, it's going to be an era of learning. So many technologies, path-breaking, cutting edge, but it requires you to learn it. Hence, it is important that you start talking to a cloud service provider, build the right kind of alliances, the networks, there are developer communities, GitHub, for example, that are there, which is almost like a social media site for developers. We need to all latch onto those kind of networks to understand what's really happening in this world. But for sure, this world is here to stay. A security conscious, app powered, multi-cloud world is dawning upon us. Let's be ready for it. Thank you.